Let's do another round of word problems. Again, we're trying to fit a linear function, f of x equals mx plus b, and we're playing around with the names. But what's different about this is there's not a clear y-intercept and not a clear slope. So we'll have to figure out how to do that, show you a trick of the trade, and hopefully these won't be so intimidating. So the first problem, in 2010, the number of graduates at Tasuka Tech High School was 215. In 2015, the number dropped to 180. So when we look at this data, it's pretty clear that no slope is given and there is no clear y-intercept, because if we take a look at the linear function we're supposed to build, right, time is going to be the independent variable and the number of graduates will be the dependent. So when I look at the data, right, one data point is in the year 2010 there were 215 graduates, and then in the year 2015 it dropped to 180. So there's my data based off of my input-output system, time being the input, number of graduates being the output, but neither one of those points is a nice y-intercept. So we don't have either one of these. So here's the trick. What we start to do is we let t equal to 0. How about we let it correspond to the year 2010? Now, what we're doing is called a transformation or a rescaling, whatever you want to call it. When you guys move into 150, you'll realize that we can take a graph that's maybe way over here on our x-axis, and we can basically move it around anywhere that I want. We can shift it, we can transform it from being way over here to way over there. So if you can imagine, if this is the y-axis and this is the x-axis, and if I have a graph that's way over here off my graph, we can basically take that graph and move it all the way over to here, where I now have a y-intercept. And that's exactly what happens here. 2010 now corresponds to time equals to 0. So this first data point is 0 to 15. And voila, what I now have is a y-intercept. This is in 2015, but if t equals 0 corresponds to 2010, this new data point is now 5 and 180. So we took care of one problem. We have the y-intercept, so I know what b is. So what about my slope? Well, we can still find the slope. Given 2 points, my slope, we basically subtract my y values and we subtract my x values. And I think here we end up with negative 35 in the numerator and 5. And so it looks like the slope is negative 7. This is basically saying that the high school is losing 7 graduates per year. And so we're ready. What's my g of t? Well, it's going to be my slope, negative 7 times t plus my y-intercept of 2015. And because we did this, if you're going to be using this model, you better tell somebody what you did. Where t equals 0 corresponds to the year 2010. So now that becomes our complete answer for letter A. That information is important for what we're about ready to do. So make sure you accompany it. If you find yourself doing that, accompany your model with that phrase. That way people know how to use the model. So there you go. So we fixed a problem pretty easily. Now how do we use it? Well, the next one says how many graduates will there be in 2020? So the time is 2020. I'm putting it into the function. Now again, if I didn't have this statement, imagine that statement was gone, we might literally put 2020 into the function, and then we're going to get something that's way off, because negative 7 times 2020 is a huge number. So it's way out of bounds of the real life situation. But because t equals 0 corresponds to 2010, what we're going to actually put in the model is g of 10, because we're 10 years after that point. And so plugging that in and doing our math, right, that's negative 70 plus 215. Let me do some math over here. So 215 take away 70. Right, I'm getting 145. So it looks like g of 10 is 145 grads. So we're expecting, according to this model, that in the year 2020, this year, right, there were 145 graduates. Of course, we can go verify that and see how good our model is, or readjust our model, but that's for your market researchers. Next question, when will there be 56 graduates? Well, this time I'm giving you an output I'm asking when does g of t equal 56? So in what time value will there be a graduate, right, of 56? So we take our model, negative 7t plus 215, and we set it equal to 56. And we solve for t. So we'll subtract 215 from both sides, right? And we get negative 7t. How about I do some work over here? I'll actually do it this way. 0, carry the 1, 15, take away 6 is 9. And that gives us 5, so that's 159. Alrighty? And then divide both sides by negative 7. By the way, that would be a negative 159. So we get t equals 159 divided by 7. And unfortunately, I don't think that's a nice, neat number. That happens a lot. So let's do some math here. 7 into 15 goes in twice. Remainder of 19, that's another twice, 14. So this looks like it's roughly 22. And what's our remainder there? 5 and 5/7. So rounding up, since we're talking years, it looks like t is roughly 23 years, or maybe 22, but since it's 5/7, we'll lean heavy towards the rounding up. So 23. Now when's that from again? From 2010. So we're talking about the year 2033. So according to this model, in the year 2033, they will be down to 56 graduates. And of course, that's what the model says. As time moves forward, we can adjust it. So hopefully you're seeing we're basically doing the same thing, just we had to work a little harder to build the model at the beginning. Next one, in the year 2000, the average price for a Major League Baseball ticket was around $16. In 2010, the average price was around $27. Find a linear function, p of t, for the situation. So again, t is serving as our input, the price is serving as our output. So when I look at my data points, 2000 is the first year, and we had an output of 16. The next data point was 2010, and we had an output of 27. And so again, let's scale this down. Let's let t equal to 0 corresponding to the year 2000. And so this gives us 0.16 and 10.27. There's my y-intercept, so we're almost there. Finding my slope, I'll subtract my y values, subtract my x values, and we get 11 over 10. So there's my slope. So what's our function? P of t is my slope, 11 over 10, times t, plus my y-intercept. So there's our model. And of course, don't forget, t equals 0 corresponds, right? We fix this to the year 2000. So put in that little qualifier statement so people know how to use my model. Using it, what is the average price in 2033? Well, again, we're not finding P of 2033, right? That's going to be wrong. But we're 33 years after, right, when we started the year 2000. So we're actually looking at P of 33. How about, I just realized something. How about we make that a nice 30-30? Okay, plugging that in, we get 11 over 10 times 30 plus 16. 10 and the 30 goes in 3 times. We have 33 plus 16, and that looks like it's 49. So according to this model, right, the average ticket price in the year 2030, so 10 years from now, will be 49 bucks. When will the price be 100? Well, we're now asking that question functionally, right? When does P of t equal 100? So what time value creates an output of 100? So we're going to take our model and set it equal to 100. And if we subtract 16 from both sides, we get 11, 10, t. I think that's going to be what? 84, if I'm not mistaken. Did I get that right? Yep. If we multiply both sides by 10 over 11, all right, t is roughly 840 divided by 11. So again, doing some quick calculation here. 11 goes into that 7 times, and I believe that'll give us a 70. 11 into 70 goes in 6 times. 66. We'll have 4 and 3. So oops, that's a point, that's a decimal point. So how about we just leave it as 4? So we have t is 76 and 4/11. So if I had to round that off, we're probably talking 76 years from now. Of course, 76 years from when? From the year 20,000, or from the year 2000. So 2076, right, will be the year where I expect the price to be $100 based off of the model. So a little bit harder to do to start. Make your scaling, make your transformation, build your model, and then you can obviously use your model by plugging something in, right, or solving an equation. And don't get, sometimes things don't come out real nicely. I did that purposely because out in the real world things are a little messy. And so that's how we kind of deal with those messy situations. All right, so one more thing to talk about with regard to this section. I'll see you guys in the next video.